All right, guys, so today we're going to be working on polynomials. So we're going to start today with just like kind of an overview of what that is. So a monomial is going to be a number, a variable, or a product of numbers and variables with whole number exponents. So that is what we've been doing for the past couple weeks now. Everything that we've been working with have been monomials. So we were multiplying monomials, dividing monomials. So that's what we've been working on, what we just tested on. So a polynomial then is a monomial or the sum of different monomials. So we haven't been adding yet. So this could be something like 2x plus 3x to the third. That is considered a polynomial because we have that addition sign in between. It's two monomials added together. To find the degree of a monomial, we want to take the sum of the exponents of all the variables in the monomial. To find the degree of a polynomial, it's just going to be the highest degree. So whichever one's largest of all the monomials. Standard form is going to be a polynomial written with the terms in order from greatest degree to least degree. And we always want it in alphabetical order as well, just like with our monomials. And a leading coefficient is just the coefficient of the first term of your polynomial. So that's a whole lot of definitions, but let's just get into looking at some of them. So this asks us to find the degree of each monomial. So here, because I have two different variables, all I'm going to do is add the exponents together. So 2 plus 4, the degree of this is 6. So we add them together because there's more than one variable. On number 2, we have no variable. So that means if we have no variable, our degree is going to be 0. Number 3, I do not see an exponent, so we have 8y, but my exponent is going to be 1, so my degree is just 1. So if there's just one variable, it's just the exponent of that. Number 4, we have negative 7xy squared. So again, we're only looking at the variables. So I have an exponent of 1, exponent of 2, so my degree is going to be 3. So all we have to do when there's more than one variable there, we just add them together. So that's finding the degree of monomial. So now to find the degree of the polynomial, all we're going to do is take the highest degree of all the monomials that we have in that polynomial. So looking here, this 4x would just have a degree of 1. 18x has a degree of 5. So our polynomial is going to have a degree of 5. So we just take the bigger of the two. Number 6, we have 1/2 x squared y plus 1/4 xy plus 3/4. So my degree here of x squared y is 3. My degree of xy is 2. My degree of 3/4 is just going to be 0. So again, I just take the largest degree, so our degree is going to be 3. Number 7, I have 6x, so that's a degree of 1. I have x squared, so that's a degree of 2. X has a degree of 1. 3 is going to have a degree of 0 because there is no exponent. So for this polynomial, the degree is just 2. Number 8, we have x to the third y squared minus x plus 2. So here we have a degree of 5, a degree of 1, and a degree of 0. So again, we're just taking the largest exponent. So that's going to be 5. So now that we hopefully kind of understand how to figure out what the degree of each polynomial is, now we're going to talk about naming the polynomials or classifying. We'll refer to it as both. So when we name polynomials or classify them, it is by the degree, which is what we just talked about, and also the number of terms. Terms are just those monomials that are separated by addition and subtraction. So as for the names, if we have a degree of 0, we are going to call it a constant. That's because there's no variable, just a number, so it's a constant. If we have a degree of 1, this is going to be linear. So most of the equations that we've worked with this year so far, or all the equations really, have been linear equations. Most of them, I guess. So those straight lines, that's going to be linear equations. Degree of 2 is going to be quadratic. Degree of 3 is going to be cubic. If you cube something, it's raising it to the third power. A degree of 4 is going to be quartic. Think of quarts, 4 quarts in a gallon. 5 is going to be quintic. And if we have anything higher, 6th degree, 7th degree, 8th degree, whatever, it's just going to be, you're going to say blank, so whatever number, degree. So whenever we are naming polynomial, we always have the degree, then we'll name it by the number of terms. So for number of terms, if there is just one term, this is that definition at the beginning that we talked about, monomial. Mono meaning one. If we have a degree of 2, it's going to be a binomial. Bicycle, 2 wheels. If we have if we have 3 terms, I think I was saying degree. If we have 3 terms, it's going to be a trinomial. Tri meaning 3, like tricycle. If it's 4 or more, that's all that we have names for. If it's more than 3, we're just going to call it a polynomial of blank terms. So polynomial of 4 terms, of 5 terms, of 6 terms, etc. So now all we're going to do is we're going to look at a couple examples and see if we can name it by degree and number of terms. So looking at this first one, my highest degree is 2, so I'm going to name this a quadratic. We have x squared as one term, plus separates our terms, 5. So we have 2 terms, so it's going to be a quadratic binomial. Number 2, we have 3x to the 5th, 2x to the 3rd, 5x, and 1. So that 5, we're going to have a degree of 5, so we name it as a quintic. We have 1, 2, 3, 4 terms. So we're going to call it a quintic polynomial of 4 terms. Number 3, we just have the number 5, so that it has no exponents or degree is 0, so we're going to call it a constant. It is just one term, so it's going to be a constant monomial. Number 4, we have negative 2x to the third minus 3x plus 7. So my highest degree is 3. So that is going to be a cubic. We have 1, 2, 3 terms, so it's going to be a cubic trinomial. Finally, we have 3y to the 8th plus 18y to the 5th plus 14y. So this is going to be an 8th degree. We don't have names for that. We have 1, 2, 3 terms, so 8th degree trinomial. And now we know how to name / classify polynomials.